Hi there, in this video I'm going to do a past exam question on differentiation. So let's take a look at this question. So question 4 part A, differentiate with respect to x, and in part 1 of A we need to differentiate x squared e to the power 3x plus 2. So let's go back to the paper and pen. So we need to differentiate x squared e to the power 3x plus 2. So let me let y equal x squared e to the power 3x plus 2 to start off with. Now in this case I have a product of two functions, so the two functions concerned are x squared and e to the power 3x plus 2. So since we have a product, let's apply the product rule. If you're unaware of the product rule, I've created a video on the product rule and I'll provide a link to this video in the description below. I also created a video on how to differentiate exponential functions, and I'll also provide a link to differentiating exponential functions, the video concerned, in the description below also. So let me show you how this product rule works for this function here. So by product rule, and here's the formula for the product rule. So dy over dx, to work out the gradient function, the formula is v du over dx plus u dv over dx. So in this case we need to choose u and v for this formula. So I normally take u to be the first term, so u is x squared, and if u is x squared, v is the remaining term, so v is e to the power 3x plus 2. But it doesn't really matter which one you take as u. If you take one as u, the other one is going to be v, so it doesn't really matter which one you choose as u. So going back to this formula, we need to work out du over dx and dv over dx. So as a side calculation, u I've chosen as x squared, so du over dx, if I differentiate x squared, that is 2x, whereas v is e to the power 3x plus 2, so let's work out dv over dx. So once again, if you're not aware or if you're not sure about how to differentiate an exponential function, I'll provide a link to that video in the description below. But let me show you how it's done briefly. So provided that the term in front of your exponential function is a constant, when you differentiate an exponential, it's the same term, so e to the power 3x plus 2, but you need to multiply by the derivative of the power. So you need to multiply by d by dx, the derivative of the power, which is 3x plus 2. So bearing in mind d by dx of 3x plus 2, that is 3. Let's make a note of that. So that would make dv over dx 3 times the term, so it's 3e to the power 3x plus 2. So that is what you should have for dv over dx. Now let's substitute this. Let's substitute this data into the product rule. So dy over dx, that is equal to v is e to the power 3x plus 2, multiplied by du over dx, and du over dx we have as 2x, plus u in this case, that is x squared, multiplied by dv over dx, that being 3e to the power 3x plus 2. So I've replaced the terms here into our product rule. Let's multiply the brackets out. Let's get rid of these brackets to give us dy over dx, that being 2x times e to the power 3x plus 2. Let's write as 2x e to the power 3x plus 2, plus 3e to the power 3x plus 2 multiplied by x squared is 3x squared e to the power 3x plus 2, Now what I'm going to do is I'm going to factorise this. So if I take a common factor of x e to the power 3x plus 2, as this term is common to both of these, so if I take a common factor of this term, I should be left with 2 plus 3x in the bracket. So that should be the solution to the derivative of this term in part 1. So part 2 of A is we need to differentiate cos 2x cubed divided by 3x. So let's differentiate cos 2x cubed divided by 3x. So back to the paper and pen. So again, I'm going to start off by letting y, so if I let y equal cos 2x cubed over 3x. Now over here, I have a quotient of two functions. So I'm going to use the quotient rule here. You can apply the product rule if you want. So you can apply the product rule if you want. So if I take this red pen, you could rewrite this as cos 2x cubed, and leaving the 1 over 3 as it is, you can bring the x upwards to give you x to the power minus 1. So you can apply the product rule based on this, but I'm going to use the quotient rule. So let me use the quotient rule. So for the quotient rule, I'm going to take u to be, so u is the top term always, so use the numerator term. V is the term in the denominator. So u is the term in the numerator, v is the term in the denominator. So let me write down the quotient rule. So by the quotient rule, dy over dx, here's the rule, v du over dx minus u dv over dx, all divided by v squared. If you're not aware of the quotient rule, I have created a video explaining how the quotient rule is applied, and I'll provide a link to that video in the description below. Let's get back to the question. So for the quotient rule, I need du over dx and dv over dx, so let's do that as a side calculation. U is always the term in the numerator, so it's cos 2x cubed. Let's work out du over dx. So when you differentiate cos, it's minus sine, so it's minus sine 2x cubed, but you need to multiply by the derivative of 2x cubed. So also, if you're unfamiliar in terms of how to differentiate trigonometric functions, I'll also provide a link to how to differentiate trigonometric functions, the video concerned, in the description below. So let's continue. So du over dx will be d by dx of 2x cubed, that is 6x squared, and 6x squared times minus sine 2x cubed is minus 6x squared sine 2x cubed. So that is du over dx. Now let's move on from there. Because v is 3x, so v is 3x, let's work out dv over dx, since we need that also. dv over dx, want to differentiate, is straightforward, it's 3. Now let's put this data into a quotient rule. Let's see what we get as a result. So dy over dx, that being v is 3x, multiplied by du over dx, which is minus 6x squared sine 2x cubed, minus, so a minus, u is cos 2x cubed, so there's our u term, times dv over dx, that being 3, all divided by, so let's take a ruler, everything divided by v, which is 3x, and it's v squared, don't forget, so 3x squared. So if I multiply, so let's multiply out, dy over dx is equal to, So minus 6x squared sine 2x cubed times 3x, that is minus 18. So minus 6 into 3 is minus 18. X squared times x is x cubed sine 2x cubed. 3 times cos 2x cubed is 3 cos 2x cubed, all divided by 3 squared is 9 x to the power 2, or x squared. So for part B is, given that x equals 4 sine 2y plus 6, find dy over dx in terms of x. So let's go back to the paper and pen. So in this case, here is what we have. So x is 4 sine 2y plus 6, and we need to find dy over dx with respect to x. So what we're going to do is we've got to differentiate both sides with respect to x. Let's differentiate the left hand side. So d by dx of x. And we also need to differentiate the right hand side with respect to x. So we're going to think about how we work out d by dx of 4 sine 2y plus 6. So we're differentiating both sides with respect to x over here. Now the left hand term, the derivative of x, we know it's very straightforward, it's 1. However, let's do a side calculation and let's calculate the derivative of that right hand term. Let's call that star. So let's work out star together. Let's work out the derivative d by dx of 4 sine 2y plus 6. Now we need to use a chain rule in order to differentiate this term involving y. So in order to differentiate the term involving y, let's use the chain rule. And here's the chain rule. We need to first differentiate that term with respect to y first. So we need d by dy of 4 sine 2y plus 6. And then you multiply that by dy over dx. So we use the chain rule in order to differentiate any function involving y with respect to x. Now, if you're not familiar with the concept of this, I have created a video explaining this, and I'll provide a link to that video in the description below. Let's move on though. So if we differentiate 4 sine 2y plus 6 with respect to y, the derivative of sine with respect to y is cos, so it's 4 cos 2y plus 6. But don't forget, you need to multiply by the derivative of 2y plus 6 also. So you need to multiply by 2. Okay? Don't also forget to multiply by dy over dx eventually. So let's move on from there. So let's simplify this. 4 times 2 is 8. So it's going to be an 8 cos 2y plus 6 dy over dx. So that is the derivative of star. So we did that as a side calculation. So let's piece this together in the main calculation. So the derivative of x is 1. So 1 is equal to, and when we differentiated the term on the right, which is named star, we had this as the solution, 8 cos 2y plus 6 dy over dx. So we have this for the moment. Let's rearrange for dy over dx. So if I rearrange for dy over dx, dy over dx therefore will be 1 divided by 8 cos 2y plus 6. So this is what we have for dy over dx. Now, if we go back to the question, we're nearly there, but the question says we need to find dy over dx in terms of x. So in this case, let's go back to the paper and pen. So let's write this in terms of x. Now, from the start, x is 4 sine 2y plus 6. Okay, so using x is equal to 4 sine 2y plus 6, let's try and make this in terms of x. So since x is equal to 4 sine 2y plus 6, so if I rearrange for sine firstly, sine 2y plus 6 will be x divided by 4. Now, if we go back to our solution for dy over dx, now my idea is if I can replace the 2y plus 6 by a term involving x, I've solved the question. So I'm nearly there. So looking at my side calculation, I have that sine 2y plus 6 is equal to x over 4. So simply, to find 2y plus 6, I can take the inverse sine of x over 4. So what I'm trying to say is I can replace this 2y plus 6 term by the inverse sine of x over 4 in order to write dy over dx in terms of x. So let's do that. So dy over dx will be 1 over, so 1 divided by 8 cos 2y plus 6, let's replace by the inverse sine of x over 4. So that should be the final answer for part B. So I hope this example was clear in terms of the method applied. Again, if you're unaware of differentiating a y term with respect to x, I'll provide a link to the video that I've created explaining this in the description below. Also, if you're unaware in terms of how to differentiate trigonometric functions, I'll also provide a link to that video explaining the process in the description below also. So that completes that part, that completes the whole question number 4. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related questions and I hope to see you again. Thank you.